Hi class, this is Professor Smith. I'm going to be doing problem number 12 on sample test 1 where we're given a polynomial and we know a 0 and we want to find the other linear factors. So knowing that negative 2 is a 0, we can use synthetic division to find the quotient. Or a better way to say that, we can use negative 2 to find out what would be the coefficients for the factor x plus 2 if you divide f of x by x plus 2. So using synthetic division is going to help us come up with that resulting quadratic. So let's do that. So we're going to take the coefficients for f of x, which are 1, 4, negative 2, and negative 12. We bring down the 1. Negative 2 times 1 is negative 2, and then we add, and then we multiply again by negative 2, and we get negative 4, and we add, and then negative 2 times negative 6 is 12, and we add and get 0. And we knew that we're going to have a remainder of 0 because x equal to negative 2 was a 0. All right, so now we have the coefficients for our quotient. You say, well, how do I know what the degree is going to be for that first coefficient? Well, since we're dividing by x and x cubed, and f of x is of degree 3, we know that the resulting answer is going to be 1 degree less. That 3 that we have was now become a 2. So this will be the coefficient for x squared. The 1 will be the coefficient for x squared. 2 will be the coefficient of x, and 6 will be the constant. Negative 6 will be the constant. So we have 1x squared plus 2x minus 6, which we just write as x squared plus 2x minus 6. So when we take that polynomial, that cubic, and divide it by x plus 2, it's going to have a resultant quotient of x squared plus 2x minus 6. Now what we want to do is factor that resulting quadratic. So we can ask ourselves, are there factors of negative 6 that add up to 2? So 6 only has factors of 6 and 1 and 2 and 3. And no matter what we do, whether we change the sign or not, they're not going to work. So what we're going to do in order to factor that is we're going to have to use the quadratic formula. So the quadratic formula states that x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A in our particular case is the coefficient of x squared, which is 1. B is the coefficient of the linear term 2x, so that will be 2. And c is equal to the constant, which is negative 6. Substituting in, we have the opposite of 2 plus or minus the square root of 2 squared minus 4 times 1 times negative 6, all divided by 2 times 1. Let's go ahead and continue this on our next page. Continuing, we have negative 2 plus or minus the square root of 4 minus a negative 24. When we multiply 4 times 1 is positive 4 times negative 6 is negative 24 all over 2. So we have negative 2 plus or minus. That double negative becomes a positive. So we have 4 plus 24 over 2, which is negative 2 plus or minus the square root of 28 all over 2. Root 28 can be simplified, so let's do that in a little thought cloud. Root 28 is equal to the square root of 4 times the square root of 6. No, it is not. If you're tired, it is. How about that? 4 times 7 is 28. And so we can break that up into 2 times root 7. You said, well, why did you pick 4? Well, it turns out because we could have picked 14 and 2, but neither 14 nor 2 are perfect squares. So that's why we picked 4 and 7, because 4 is a perfect square. So it's equal to 2 root 7. So simplifying, we have negative 2 plus or minus 2 root 7 all over 2. Simplifying again, because all the terms are divisible by 2, the denominator is divisible by 2. Negative 2 is divisible by 2, and so is 2 root 7. So when we divide each term by 2, we're left with negative 2 divided by 2, plus or minus 2 root 7 divided by 2. Negative 2 over 2, that cancels, and that leaves me with a minus 1. Plus or minus, the 2's cancel when you have 2 root 7 over 2, leaving me with root 7. So our two answers are x equal to negative 1 plus root 7 and x equal to 1 minus root 7. Once we have a 0, we know that we can now write a factor. So we have x equal to negative 2. That lets us know that we'll have the factor x plus 2. X equal to negative 1 plus root 7. How on earth am I going to figure out what that factor is? Well, one way to think about it is to rewrite this expression so that we have 0 on the right and everything else on the left. So in order to get 0 on the right, I would add a plus 1 to move the negative 1 and subtract root 7. And so that'll leave me with x plus 1 minus root 7 equal to 0. Therefore, I know that a factor will be x plus 1 minus root 7. Similarly, when I have x equal to negative 1 minus root 7, adding a 1 to both sides, so x plus 1, and adding a root 7 equal to 0, that lets me know that my other root is going to be x plus 1 plus root 7. So I said root, I hope I said factors. So now I have my factors. So if you know you have these values as zeros, then these guys on the right will be factors. So now I can write my polynomial f of x. It's going to equal x plus 2 times x plus 1 minus root 7 times x plus 1 plus root 7. So those are going to be the values that will work for rewriting our polynomial as a product of those linear factors. So I hope this movie on problem number, I believe it was 11, was helpful for you.